The kind that have teased and troubled mankind for hundreds and thousands of years.
And there were men through all these ages who tried to find the answers. But the answers they found were never completely satisfying. Always there was something wrong. Some fact, some little fact, that proved the answers false. The first really useful answers began to come only 100 years ago, and they came from a little town in Austria. And the man who proposed those first answers was a monk in the monastery of Brünn, a monk named Gregor Johann Mendel, a quiet man who raised peas in the monastery garden, who measured the height of each plant, carefully harvested the pods, and counted the seeds in each pod.
1, 2, 3 green, 1 yellow. You have that, Michael?
Yes, Father.
Good. Now, 2 yellow.
2 yellow.
2 green.
2 green.
Now, 1 green, 2 yellow, and...
2 green.
No, Michael. 1 green, 2 yellow.
You go too fast, Father.
Yes, maybe I do. But there is so much to do here that I...
Father.
What is it, Michael?
Excuse me, Father. I've been gardening all my life, but never before has anyone counted the seeds in a seed pod.
No, I suppose not. But I have a reason.
Oh, yes, Father, I know you have, but I don't understand.
But I do, Michael. Or I think I do.
Yes, Father, yes.
Oh, don't apologize. I like to talk about my work. And there are so few who will listen.
Yes, Father.
Especially now, since the work is almost done. And the time has come to put my findings down in writing.
Writing?
Now, Michael.
Yes.
I have learned that when 2 different types of plants are mated, all the offspring will be alike.
But I'm a gardener. I've seen that.
I'm sure you have. Now, the name I give to that fact is the law of uniformity.
They're all alike, yes.
But
yes, Father.
When these offspring are mated, the resulting generation will not be uniform.
No.
But this new generation will have different forms. I call this the law of segregation.
Every gardener knows that, Father.
So?
Well,
these differences come in groups according to a definite numerical ratio.
Numerical rate.
And that is, Michael, there is always a certain number of each kind. Always.
Always a certain... Oh, so that's why you count the seeds, Father.
That's why I count the seeds. And that's why the count must always be correct.
Yes.
But, Michael, the law of segregation goes a little further.
So?
My experiments show that inherited characteristics go in pairs of opposites, such as tallness with shortness, or yellow seeds with green seeds, or, well, smoothness with wrinkles. So when I mate a pure tall plant with a pure short one, the offspring will all be tall.
They will all be tall. Yes,
Even
Father.
though one parent is tall and one is short. You see, that makes tallness dominant over shortness.
Dominant?
Yes. Now, when their offspring unite, the result will be that some are tall and some are short. But there are more tall ones than short ones. Shortness, you see, is recessive.
Recessive, yes.
Yes, the parent plants in the second mating have a mixture of characteristics. And the shortness comes out in the offspring only when they receive a short characteristic from both parents.
Good, Father. Good, but maybe we'd better go back to counting.
What? Oh. Yes, Michael. Maybe I'd better leave the explanations until the work is done and the writing begins. Ready, Michael?
Ready, Father.
1 green, 2 yellow.
1 green, 2 yellow.
1, 2, 3 green.
The slow counting continued from spring planting to autumn harvest, season after season for 6 years, and at last the work was done. The writing began, and then the writing, too, was done. And finally, in 1866, it was published. But no one, not even the great Charles Darwin in England, nor Mendel's best friends in Europe, paid any attention to his paper on experiments with plant hybrids. In his little monastery cell, Mendel waited for word that someone, somewhere, had read his paper. But no word came.
It is too bad. For the work I have done with plants can be applied to animals, even to man. But that work is for other men to do. My day will yet come, My day will yet come.
But Gregor Mendel was never to see that day himself. On a raw, gusty day in January, in the year 1884, he died. The century grew older, and Mendel's paper on hybrid plants lay forgotten in dusty libraries. The century closed, and men turned their calendars to the year 1900. In March of that year, in Amsterdam, Holland, another scientist, Hugo de Vries, made a discovery, an important discovery.
Mendel. Gregor Mendel. Why has nobody mentioned him before? Mendel.
What now, Hugo?
Oh, this paper on hybrids.
What about it?
Listen, wife. This paper was written almost 40 years ago, and the conclusions it comes to are the same as mine.
Really?
And more than that, the proof is better than mine, more complete, more precise. This paper by Gregor Mendel is a masterpiece, one of the greatest works of science in the last century.
But you're going to publish your work, aren't you?
Yes, my dear, of course, but only as another proof that Mendel was right. I'm going to tell the world of science that Mendel found the answers 40 years ago in Austria.
That was the word that Mendel waited for and never received. That was the beginning of the modern science of genetics, the study of life and how it passes on from parents to offspring, from generation to generation, in plants, in animals, even in man. That was the beginning. In Mendel's work, the scientists of the new 20th century found the answers to old, old questions. But even more than that, they found the courage to ask still other questions and work for the other answers. One of these new questions was this.
How do the characters of parents pass on to their offspring?
Mendel had proved that the passing on of character took place in certain definite ways. The new scientists of the 20th century wanted to know how. One of these questioners was Thomas Hunt Morgan, a professor of biology at Columbia University in New York. But for him, the breeding of plants was too slow. He needed something that grew fast, whose generations came in short spaces of time. And he found what he needed. A fly. The vinegar fly, whose span of life from egg to full-grown adult was only 10 days. Now he could study inherited characters in numbers beyond anything the older scientists had found possible. 30 full generations in 1 year.
These little insects are the key to the puzzle. Breed them in hundreds and thousands, generation after generation. Study them under the microscope, and the answers will come. Keep accurate records. Count, examine, study, work hard. Be patient. And the answers will surely come.
And the answers did come, as Morgan said they would. And one of the answers became a new theory in the science of genetics.
This is what we've learned from our thousands of little vinegar flies, that the characters that an individual inherits from its parents come from special elements in the parent cells. These elements we call the genes, and they unite according to Mendel's two great laws. The genes control the characters that parents pass on to their offspring.
But there was much more to come from Morgan's buzzing flies. Take the year 1914. It is late at night. One of Morgan's students, a young man named Herman Muller, is still at his microscope. He does not hear a step behind him.
Oh, Muller? Huh? Oh, Dr. Morgan, I didn't hear you come in.
So I noticed.
I was so busy. I've been studying this specimen all evening. There's something here that I don't understand.
Oh, well, suppose you let me take a look.
Yes, the wing. The wing is bent. You see, sir?
Yes. Bent wing.
It's a new characteristic.
Well, so what's your problem?
Well, just this. If the bent wing should not combine with other traits in the next generation, then, well, you see, sir, we've found an entirely new principle in genetics. We've found a new species in the very process of coming into being.
Yes, Muller. This is new. And if it turns out as you say, and you can prove it, this will be the beginning of a great career.
And young Muller's guess proved to be right. Another question in the science of genetics had been answered. The vinegar fly was now as famous in the world of science as the peas that Gregor Mendel tended in his monastery garden. Even today, as we speak now, that same fly lies under the microscopes of scientists the world over. And the answers come fast. And the questions come even faster. For a new horizon has been lifted in man's search for knowledge. A new science has risen in one generation of men to the stature and strength of even the oldest of sciences. Mendel was the beginning, yes. Morgan carried it forward, true. Muller follows now with new discoveries. And one of the great new centers of work is Indiana University, where Muller and his colleagues search for new and accurate answers to questions that are as old as mankind itself.
You have been listening to another program from Great Days in Science, the Indiana School of the Sky Science Series. The script was written by George C. Johnson, Director of Educational Radio Programs at Indiana University. In the cast were John Taylor, Bob Messy, Gerald Thomas, Lamar Kraft, Dolores Cawley, Julius Miller, and Richard Morgan. Sound and music by Eldonna May. The program was directed by John R. Mickey.
Next week, the final program of the 1949-1950 Indiana School of the Sky Science Series. A program called Many Questions Still Remain.
This series is produced by the Radio Department of Indiana University and reaches you through the cooperation of the Indiana State Department of Education and this radio station.